All right, so what we're working on today is getting down some of the basic geometric terms, and then maybe doing things like working with lengths for segments and bisectors, midpoints, so on. This is like real basic stuff. This is stuff that's going to be your building blocks for the rest of the course. Okay, so to start with, there are 3 undefined terms that make up everything or every other shape or figure that you're dealing with in geometry. Okay? That's going to be the first 3 that they have, like if you're looking in the book, on that page 3 there, the point, line, and plane. Okay, now they give you a little definition for what's there, but I'll give you also representation. We'll talk about how to name them, because that's, again, all key to you being able to correctly communicate with someone in this class or on a test or whatever. Okay, so the point is your most basic thing in this class. All right, all a point, as it says there, it should say there, all it does is represent a location. It's not like an actual figure that you're looking at. Okay, all it does is it's tell you an exact place that you want your eyes to kind of trend towards. So all that you use is a dot. I think most people would probably guess that for a point. And when you name these, you always want to name them with a capital letter. You put whatever letter down you want. I don't care. Okay? A, B, C. Just make sure it's a capital one. Because when you do lowercase, that usually represents something else in here. Again, depending on what we're working with. And when you name these things, so this would be like if you're doing it in the chart, that would be the representation. When I say naming, that's what they have as notation up there. There's no fancy way to put points. It's literally you write the word point and then write the letter that's right next to that dot that you want them to look at. No big tricks there. Okay? Then the next one up would be a line. So if you take 2 points now, so you start with a single point, that's your most basic. If you take 2 points, you can connect them with a line between them. Give me a letter.
B.
Oh my gosh. B and what? B. Sure. Okay, give me another letter.
F.
F. All right. So I put those 3 on there. 2 of those letters that we put up there are points because they're capital letters. The other one is just labeled next to the line to identify. We can also call this line F. When you write these out, if you're doing it with the points, you just pick any 2 points that are on the line. Obviously, there's only 2 that I put on that line. If I put more than 2, you just pick any 2. You write those 2 points out in any order. So BD, or you can write it like DB, and then you draw a line on top. The arrows are very important there. That's how you specify a line, because a line has no ending point. It goes on forever in each direction. All right, which again is hard. You can't represent that on paper. That's why you put the little arrows, just representing that it goes in that direction for infinity. It goes that direction infinitely. The literal letter at the end, which would be a lowercase letter, and again, it doesn't matter what letter is there. You can also call it line F. Keeping in mind, right, that the lowercase ones are never the points, so don't include those with the other 2. Then if you add one more point to it, so we have 1 point, this has 2 points. If I go up to 3, you got a plane. What letters can we do here? C, D, and E. Sure. Give me one more. What? No, someone else. You gave me enough already. Give me one more letter. Wait, what? Z? Z. Okay. So now, for notation here, there's no tricky notation like with a line. You draw the letters with like a line on top. Just like with point, if you're dealing with a plane and you want to identify the plane, you write plane. Then just like with the line, you either pick the points that are on the plane, but you only have to list 3 points. You have to list at least 3. Okay, you never really list more than that. I guess you technically could, but it's just creating more work and more writing for yourself. The order of the points don't matter. And again, this is like a flat surface, which goes on for infinity in whichever direction you're looking at, just not three-dimensionally. So I could write this as DEC. I could write EDC, CDE, whatever. It doesn't matter the order of the letters. Okay, it just has to be 3 points that are on that flat surface. Majority of the stuff we do in here is planar geometry, meaning everything is on a flat surface. So if you see points, essentially that's going to be on the plane you're looking at. The little letter off to the side, again, just like up here, I could also call it by that letter, the Z. Okay, and I know that's not a point because there's not a dot next to it. It's just a letter that's associated. Usually, they'll put it in one of the corners of a plane if you were looking at it, just so you don't get it messed up or mixed up with the points that are there. Okay? All right, now, the other things that are going to stem from this, because these are like your building blocks for everything else. We put a few planes together, you'll make a three-dimensional shape. If you throw some lines together, you can make like different types of angles. You can make different types of polygons with lines together, so on. Okay, so these are like your building blocks. All right, so we'll go from lines. Can I erase that point thing up there? Does anyone need this here? All right, so from the lines, okay, there's going to be two other figures that you're going to work with based on solely the lines. Okay, that's going to be your segments, all right, and your rays. Are those on there? Oh, yeah, they are. Look at that. Okay. Your segments, right? It's basically what a segment is. It's just looking at a portion of a line. Come on, give me some other letters. Some we haven't used yet. Sure. Okay. So if I was looking at line GK and I took those arrows off at the ends so that it's no longer going on in those directions forever, I'm looking at a specific area that was on that, or not, a specific part of that line. And I'm saying I'm only looking from point G to point K. That's creating a segment. Okay, segments have specific lengths to them because they don't go on forever. Lines don't have lengths because they go on forever. All right. Your notation for these, it's going to be very similar to what the line are, except for we don't have like this option here with like the lowercase letters, but we do have the 2 points that are on it. Now these are your endpoints, okay, that, and you always name it with the endpoints. Order doesn't matter here, because still, whether I look at it from G to K or from K to G, it's going to be the same length. The only reason that the lettering would matter is if it changed the length of that specific segment. Okay? So it would be GK and then a little segment on top of it. Again, no lines or no arrows. If you put the arrows on there, you're talking about a line. If I want to talk about a segment, you drop the arrows. All right? And then a ray, you could technically say it's half a line, but you can't really take half a forever, so that's really not the best way to remember it, but a lot of people can remember these as half a line, because if you just take the one arrow off, you're essentially creating a ray. Okay? You're still going to have 2 points on it. R? R and what? H? That's the first one I heard. Okay? Now, this is going to be the starting of where ordering is going to matter. All right? You're always going to, when you name a ray, when you do your notation for a ray, you always start with your initial point, which is the dot that doesn't have the arrow with it. Okay, so if I'm naming this, I'm starting at R and then it's passing through point H. All right, that's the way the arrow is pointing. So I'm going to name it RH. Okay, and then again, just like with the other notations, you just draw a little whatever the heck you're working with on top. A ray is an arrow in one direction, so you draw that on top. Okay, now, if you did ray HR, it's a whole different ray. Okay, you got to make sure you don't switch them. If, let's say it was going the other direction, now keep the letters the same, R and H. You still name it the same way. Okay? When you write the notation out, the arrow that you use for a ray is always going from left to right. So it's always pointing to the right. So even though that ray is going to the left, you don't write it like this. That's not right. Okay? Your ray notation always needs to be pointing off to the right. That's a common mistake with this stuff. All right? And just in case you see these, the starting point there, you'll use the word initial point. So initial will always mean like starting. If we get to it, like terminal might be ending point when we get to that specific thing. So we're kind of building, right? I did points, lines, and planes. Then you go to a line, and you start messing with it. You create segments and rays. The next basic term would be building off of these things. So if you take rays and start throwing them together, create angles. Can't have shapes without angles because that's what is at each vertex for a specific shape. Okay? What an angle technically is, an angle is, this is two rays with the same initial point. Okay? So the same starting point, if you stick those two rays together at that one starting point, and you got two rays going in different directions, you're creating an angle. All right? They can have a specific degree measure with them. In here, you guys go from 0, which would be just a ray in one direction, all the way up to 180 degrees, and that's it. So you guys really only work from 0 to 180. All right, so let's say if I started with that RH that's up there. It's H. And I draw another one this way. Give me a different letter. T? Wait, Q is a good one. We haven't used A yet. It's weirder. Okay, now notation-wise with this for angles. There's two different ways that you can name these. All right? One way, I guess you could say, is a little lazier than the other way, and can down the road get you in trouble. It's fine when the angle's sitting by itself, and that's using this point right here. This point right here, where they come together, that's your vertex. Vertex is always the point where the two rays come together. When we start talking about like triangles, quadrilaterals, pentagons, whatever, anytime you see two rays or lines joined together, they're creating a vertex. Okay? You're naming for this, the two ways to do it. You can either name it simply with the vertex of that angle. So if I can look at this and see that that point R is the vertex, I can just name that angle R. And when you do it, the angle thing is like a bent L, essentially. Keep in mind that this point here has to be the vertex when you name it. The other way to do it, and this is probably the way that I would suggest doing mostly, but keep in mind that the books or tests will identify angles with a single letter, is you still put the vertex in first, but it's going to be in the middle. You're going to use 3 letters on this one. The other 2 letters are just the other points on the rays, and it doesn't matter the order of it. The only thing that matters when you do 3 letters, vertex has to be in the middle. Okay, so on this one with the 3 letters, that has to be a vertex in the middle. Okay, and on either side of it are just the 2 rays that it made up of. Okay, so this is, that angle is made up of, there's ray, oops, I'm not doing that. I'm not writing the word. Ray RH and ray RQ, they create that angle that's there. Okay, or so again, order doesn't matter here, or I could call it H or Q, that works as well. Right? Now, the reason I said this one right here can get you in trouble, like where you're not necessarily going to be able to use it, would be if you had a case where, probably get into this more next time, but if I had this going on, which I'll just do A, B, C, D. How many angles are up there? 3. Okay? There's one here, there's one here, and then there's the big one there, like if this ray was gone. So if I just was like looking at this and I just said angle B, which one am I talking about? No, I don't know. You can't be sure of it. All right? So if you see a single angle, that's fine. Here, where there's a case where there's multiple angles kind of joined together, you always have to specify, even if you're talking about the big one. Like if I'm talking about the big one, I would call it ABC, because if I traced it out, point A and point C are on there, yeah, B is the vertex. If I wanted to talk about this one right here, that would be ABD, and this one over here would be like DBC. Okay? So the single letter, not always the best option. It's good if you got angles sitting by themselves. Otherwise, it's not good at all. So for the other terms they got there. Parallel lines. All right, there's going to be some notation to go with this as well, which they should have a little section there for. All right, so parallel lines. Do you guys know what these are? What? 2 lines that never intersect. So, right, so 2 lines. I'm going to throw you for a loop here in a second. All right. There's another pair of lines that never intersect as well, but if we're talking about single flat surfaces, this is the only one that exists. All right, so this would be like there. Parallel lines always have to go the same direction as each other. So if they're not going the same direction, there's no way they can be parallel. They're going to intersect, even if the little snapshot is. Like if I drew one here and here, they'll eventually cross. So I understand they're not parallel because this one eventually, if I extended it out, would go here and that would extend there. They would intersect at a certain point. Okay? So parallel always have to go in the exact direction that is there. For your notation wise, well, there's something used. Give me a starting letter. Give me a letter. S, T, P, V. There you go. That's good. Okay. All right, so I got 2 lines there. I got ST and PV, and I've already told you I want them to be parallel, even though I'm sure I haven't drawn exactly parallel lines, specifying they are. The little symbol that you use to say that these two are parallel and will never intersect just looks like an extended 11. Okay, it's going to be a little bit longer in between, but it's basically you drawing 2 parallel lines between them, but they should be vertical when you draw them out, or as close to vertical as you can get them. If I were to take this idea and throw it into like a 3-dimensional plane, you would also see a thing called skew lines. You can write this as like a side note. Skew lines, they never intersect also, but they go different directions. So, like, if I wanted these two to be skew lines, the only way they would cross and not touch is if you like lowered one below the other one. So you would actually be on a 3-dimensional plane as opposed to a 2-dimensional plane, which is what you're working with. When we talk about being in like a planar geometry space, it's 2-dimensional. Okay? These are lines that never intersect, but they're in a 3D kind of realm. Okay? Like one's going this way and one's passing underneath the other one, so there's no way they touch. The only way they would touch is if they were down on top of each other. Okay, but for the most part, this is what you work with. Just understand this is not the only set of lines that don't intersect. And then perpendicular, they got the definition there? It's what? Yeah, so lines that intersect, but they got to make a right angle. We'll just call this A and B. Okay, so we got line A, got line B. If I'm representing a right angle, or if you need to, or if the book represents a right angle somewhere, what you will see, guys, is a little box like that. Okay, and again, as a side note, right angle is 90 degrees. Okay, so this little box symbol right there means that's making a right angle. You know, a lot of stuff we'll go through multiple times. This is just to give you an intro to this stuff. Your notation for this is, here's my two lines, my line A and line B. It's just like an upside down T. So the little upside down T always means that you got a 90-degree angle in there, a right angle, whatever the question's asking for. Okay. All right, I'm going to go back to one thing with segments, and I'm going to have you guys do a few problems in that book there. For like a classwork, kind of break it up. Okay. This is something you're probably going to have to add off to the side or write out off by yourself. Okay, understand, right? We talked about segments have specific length to them. That's what makes them a segment. You're taking a line, you're cutting the ends off of it, so you're looking at a portion of it. That segment length, this is just a number value associated with the segment. Okay? They could put units on it. They might not. Might just have a number on there. When we get to like doing the stuff in the coordinate plane, you'll be using distance formula to get there. So on. Okay, but for right now, we'll just say there's values to it. All right, so give me a number. Sure. All right. Okay, now you will need like a notation thing for this. So I would suggest if you need to add the notation. The segment that's up there. Okay, I've got endpoints A and endpoints B, right? If that was a line, it would have the arrows, has no line, so I know it's a segment. So I know right there that thing exists. Okay? When you put a number value on it and you want to tell someone you're looking at the length of that segment, or if a number represents it, or if an expression represents it, the notation for it is just the two endpoints with like nothing on top of it. Okay? So if you see it written this way, where there's nothing on top, they're trying to tell you this is the length of that specific segment. Which if I have a 3 there, I know that equals a 3. Okay, so just to kind of differentiate between all of them, right? Right, a line would be like that. Array be like that. Segments like that, and length is like that. Okay, so pay very close attention to what you're writing notation-wise, just so that you make sure that whatever you're trying to convey gets through. All right? All right, now, next thing with this. All right, next thing is segment addition. That I'm going to talk about, then I'm going to have you do some problems, okay? All right, so the segment addition. Now, this is actually a thing called a postulate. What you'll see is like properties in here get classified either as like a definition, a postulate, or a theorem. Those are the three main ones. There's also an axiom, but you don't use those as much. Definitions are straightforward. You guys are all familiar with a definition. It's the same in any class. It's defining something. What a postulate is, it's a property that is like, it's accepted without proof, meaning it's pretty common sense. Meaning that if I took, let's say that segment we had there that was AB, that was 3, and along comes another one. We'll say this is like BC, and give me another number. 4. Okay? If I put those together and joined them, how long would the segment be? Okay. Does everyone disagree with that? If I took a segment that's length 3 and a segment that's length 4 and I put them together, it would create one that has a length of 7. Yes? Okay. That's what the thing is saying. Okay, now what you're going to see is because in here you have to kind of explain why you're doing certain things. You need reasons or why you're allowed to do things. Postulates, definitions, theorems are going to be like your reasonings. So if you did, hey, I put these together, right? That was 3, that was 4, and I said segment AC is 7, and someone said why, you just say segment addition postulate and you go about your business. You don't have to really do more than that. All right, because it explains it. Okay? All right, now, that basic idea usually is fine. Where you're going to have to do some work probably is, let's say we had another 2 segments joined together here. All right? I don't know. Give me letters here. Give me one letter. W. Give me another one. C, Y. Okay. All right. So let's say I started you with that picture. You saw it there. There was a segment here, right? This is segment WZ. This one here is ZY. Okay? Let's say I told you WY equals, give me a number. How long do you think WY is?
7.
Wait, what? I already did 7. Another one? 9? Sure. 9. Okay? Let's say I told you that WZ is, we'll say X plus 2. ZY is, I don't know, 2X minus 1 or something like that. Okay? I said solve for X. Like, if I looked at it like that, a lot of people have trouble with it. What usually makes it easier, at least in the beginning, is go ahead and like put everything on the picture that they give you. Meaning that give yourself a little marker from there to there, knowing that that is 9. Right? WZ, like from here to here, that's X plus 2, and from here to the other side is 2X minus 1. Okay? Kind of so you can visualize the fact that if you take this segment and this one and put them together, that creates the big one, which is the same thing we did there, just with numbers, which usually that's fine. You get here and people's minds go like just blank. I don't know. All right? But again, the idea is if you take the 2 small ones, add them together, that's going to equal whatever that bottom part is, so you can create your equation. So if I just said I want you to solve for X, find the value for X, whatever, my equation that I would set up is going to be X plus 2 plus the 2X minus 1 equals 9. All right, well, how do I go about solving that? What do I do first? And that'll give me what? Plus 1? It's 9. Then what? So if I subtract 1 from both sides, I get 3x equals. And then what? 5 by 3. It doesn't divide evenly, so 8 over 3 is fine. If you want to make it a decimal, I don't know, do extra work, have at it. I wouldn't do it. For a point, anything that had a dot with it, as long as you weren't using this letter, that one, or those two right there, then you're fine. So point D, B, whatever, F, doesn't matter. Same with the lines. Technically, if you pick any two of the points, you can put a line between them. So if I get this on a test and you want to argue that point with me, as long as you could back it up with the idea that you understand through any 2 points I can draw a line, then that's fine. I would probably think people are going to pick ones from that line that's going through the middle, so I could say something like line CD, AB, AC, AD, BC, BA. There's a whole bunch of options there. You could even do EC, even though that line there doesn't have the arrows on it. If I extend it, it would become a line. And since it's on a plane, it does extend forever, so technically it does go through that way. For segments, again, you could pick any 2 points that are on the lines that are up there, create a segment with it. Like if I wanted to stay on that middle part, AC is a segment. All right. EC, FD, DB, CD, any of those would be a segment. For a plane, you would have to use the letters here because they only give you 2 points on each plane. So since I don't have 3 points somewhere here, you have to use one in the corner. So you could say either plane P or plane M. All right? Because points A and B are not on those planes. They're somewhere on either side of them. For array, again, as long as you start with an initial point and go in the direction of an arrow, like if I wanted to do DB, that'd be a good one. I could do CA, it's another array. Keep it in mind that you don't flip it. Don't do like CA with the arrow going the other way. Okay? For an angle, ACE would be a good one. FDB would be another one. You could actually pick ACD. Like angle ACD would look like this. But it's still technically an angle. This thing is just called a straight angle. All right. So line, if you got 3 points on the line, you can always create an angle in there. Parallel lines would be like EC and FD. Okay, perpendicular ones. Wait, that's next, right? Yeah. Be like AC and EC. All right, and then the addition part. If you just took this chunk that was up there, ACD, and did like AC plus CD equals AD. Oops, that's a C. D, and that'd be fine. Anything that's got 3 points, any chunk that has 3 points, you could use. Like you could use AC plus CB equals AB, blah, 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 so on. Okay? There's a few different options there on that one. This one here, if you see a section at the beginning of a sentence that says like C lies between A and D, that's telling you that A and D are the endpoints. C is somewhere in there. I don't care where you put it. It doesn't matter. It doesn't even have to line up if you just draw it first. Like that. And then throw your numbers in after the fact. Like CD is 13. AC is 7. So if I put those together, it's how much? What's 13 plus 7? 20. Yeah. All right. And then the one down here. This is 3x plus 6. That's 2x plus 4. Whole thing is 30. So just like with the one I did up there, if you add those two together, so like 3x plus 2x is 5x, 6 plus 4 is 10. I've got an equation I can solve to get x, but then the question's asking for the actual measure of this, so once you get the value for x, you got to plug it in. So what's 3 times 4? It's 12 plus 6. So this is 18. A midpoint, you're only going to have a midpoint if you're looking at a segment. I can't have a middle of a line because, again, a line goes on forever. I don't know what the heck half forever is, and I'm not going to look for it. All right, so, gosh. All right, just for the sake of, like, when they first introduce them, M will be like midpoint because M's mid, you get it, right? Starts with the same letter as what the word is. What a midpoint is, this is in the middle, okay? Which means it's going to cut segment in half. All right, meaning that if I know how long the entire segment is, if I throw a midpoint in there, I automatically know what the smaller ones are going to be. Okay? Because that means that if this is the midpoint here, M, I know that this side over here has to equal that side over there, or else I'm not directly in the middle. Okay? You're just cutting something in half, which is also going to be the word bisector, which we talk next time. Bisect midpoint is cutting things in half. All right, which is key to kind of setting these up. So again, if I knew things like if AB was 12, so if this whole thing was 12, how long would this part be? It'd be 6, it'd be 6. Easy. Okay. Now, and on like a side note to all this, since I have those set equal to each other. Right? So if I bring that over here, just what I wrote, AM equals MB. Does anyone know another classification for two things that are equal to each other? There's another word for that in here. Starts with a C. What? It's called... Yeah. All right, so congruent will always mean that things are the same. Okay? This is where distinctions get a little, especially in the beginning of this course where this kind of throws people. All right. When you put an equals there, that makes things congruent and vice versa. If things are congruent, they're also equal. There's a reason you have two different words, though, for those. The equality thing, like what we have here, equals always goes with like the number value, okay? Whereas congruency is you talking about the actual shape that's there. Like remember, if I don't have a line on top of this, this is saying that the measure of segment AM equals the measure of segment MB. And measurements are all number values. If things are congruent, this is you talking about like the actual figure, shape, whatever the heck is going on there. So if I was saying that, hey, since they're equal, they're also congruent, if I'm going to write this, again, when we get to this further down, we'll talk about it a little bit more. You'd write it with the segments. Because again, if I throw a little bar on top, that means segment AM is the same size as segment MB. And when you talk about things being the same size, you're talking about congruency. Which in turn means they're equal, but in terms of writing terminology correctly, or for you writing things correctly in here, the notation's a little different. And the congruency symbol is like an equal with a little squiggly on top of it. All right? And then the figures, what you'll see is when you look at segments, they'll put like these little lines there. So if I saw, here's like a random thing, here's ABC. If I saw that picture and they put those little lines there, that's telling you that this segment here is the exact same size as that one right there. Even if I did in the same picture, if I drew another one over here with the same thing, that also means this one that's detached from over here is also the same size. So if you found a number value here, let's say it's 10, it means I can put a 10 there, put a 10 there. Anywhere I see the one thing, I can put a 10. All right?